In this lesson, we're going to talk about a couple different inequalities that deal with triangles. The first one is going to refer to as the exterior angle inequality theorem, and this theorem is dealing with the measure of the exterior angle and angle 1 in my picture, and then the relationship between the two remote interior angles. What I want you to think back to is that exterior angle theorem that we had that said if we took the measure of angle 2 and the measure of angle 3 and added them together, it would equal the measure of angle 1. Well, in this theorem, it's going to look at just the relationship between the measure of angle 1, the exterior angle, and the measure of, say, angle 2, one of the remote interior angles. Well, if I have to add the measure of angle 2 and angle 3 together to make it equal the measure of angle 1, then the measure of angle 1 is going to be greater than just the measure of angle 2, and it's also going to be greater than the measure of just the measure of angle 3. So when everything's all said and done, there's what it looks like in inequality format. The actual theorem, as you can see here, it tells you that if an angle is an exterior angle of a triangle, then its measure is greater than the measure of either of its corresponding remote interior angles, which is kind of just a takeoff of the exterior angle theorem. Now the other inequality that I'm going to look at, I won't show that yet. Some of you that already have the notes have already seen it, but comes from this. And what I like to look at is the different relationships here. Now notice I have this color coordinated, so this one is really angle A. There's segment BC, that's pretty easy to see. Here's angle B and here's angle C. Now what you should be looking at here is, notice the measure of angle A. Actually, I'm going to start here with the measure of angle C. It's the smallest angle in the triangle right now. I come over here to the sides, the smallest sides right here. Biggest angle in the triangle right now is angle B. The biggest side is segment AC. And then when you go medium, or the middle angle, that's angle A right now, and the middle side is segment BC. Now if I change it, maybe now it looks like this. Smallest angle now is angle A. Smallest side is segment BC. Biggest angle is angle C. Biggest side is segment AB. So as you see this and as you move it around, doesn't matter where it goes, but if you know where the smallest angle is, the smallest side is always opposite. If you know where the biggest angle is, the biggest side is always opposite the biggest angle, which when I come back here is what my two little statements say. Kind of put this together, so if you kind of start off and just read the biggest angle is opposite the biggest side, the middle angle is opposite the middle side, or the smallest angle is opposite the smallest side. Now the actual theorem is worded a lot different than this, but I think this is a real easy way, or an easier way to remember the two theorems that are being talked about here. So just keep those in mind. We had this inequality. This is my first one that I talked about today, exterior angle inequality theorem, which compared one remote interior angle to one of its corresponding remote interior angles. Or excuse me, I think I said that wrong. One exterior angle with one of its corresponding remote interior angles. And then this one, that the way I look at it, it just says the smallest angle is opposite the smallest side, the biggest angle is opposite the biggest side. And those are the inequalities that we're going to look at today.